Okay, in this first part of Objective 4, we introduced inverse trigonometric functions. And so you see here a list of the functions as well as their restricted domains and range. So definitions of inverse trigs, you have that y is this is called inverse sine of x if and only if the sine of y equals x. And so you notice here that inverse functions, what's happening between an inverse and its original is that the x's and the y's are switching spots, right? If I swapped these x and y, I would get the sine of y equals x. Now we do have a restricted range in this particular case, or a restricted domain of our original function of between negative pi over 2 and pi over 2. Cosine, inverse cosine, has a restricted domain or range of 0 to pi. Tangent is negative pi over 2 to pi over 2. It's linked to sine because tangent is equal to sine over cosine. It's sine dominant, so they have a similar domain and range. And then cotangent also is 0 to pi, similar domain and range to our arc cosine, because again, cotangent is cosine over sine, so it's cosine dominant, and so it will be linked there. Okay. Secant, or I should say inverse secant and inverse cosecant, as the reciprocals of sine and cosine, would therefore also be linked to their respective sine or cosine. Cosecant would go with sine, secant would go with cosine. And so over here we have just a depiction of those restricted domains and ranges. So sine, cosecant, and tangent, again, we will always be naming values between negative pi over 2 and pi over 2. We'll name values specifically between negative pi over 2 and 0 if the number we are trying to evaluate is negative. And we'll be naming values between 0 and pi over 2 if our number is positive. Cosine, secant, and cotangent, we are again naming between 0 and pi for these. We're going to specifically name between 0 and pi over 2 if our value is positive that we are evaluating, between pi over 2 and pi if our value is negative that we are evaluating. Okay? And so then below you have a reminder of your unit circle, pi over 3, pi over 4, and pi over 6. Quick reminders from prior lessons that pi over 3 has a cosine of 1/2 and a sine of root 3 over 2. Pi over 4 has a cosine and sine of root 2 over 2. And pi over 6 has a cosine of root 3 over 2 and a sine of 1/2. Sine, just as a reminder, is the y value, and so you'll notice I put the s above the y. Cosine is x, and then tangent is y over x, or sine over cosine, for those who prefer to think of it that way. Okay? And so then we practiced evaluating this. Number 1. So I'm going to recommend kind of watching me do maybe 1 or 2 of them, and then pausing the video, trying some after that on your own so you can get the gauge. Am I actually understanding what's going on? Or is there something I need to come in and get extra help or ask extra questions, that kind of thing? Okay? So number 1, we have arcsine of 1/2. So first thing you're having to do when you're evaluating arcsine is identify what quadrant am I even going to be considering the values of. So sine, one more time, sine we are always considering between negative pi over 2 and pi over 2. Negative pi over 2 to 0 for the negative, 0 to pi over 2 for the positive. Since this is positive 1/2 that we are evaluating here, we are going to be looking at numbers between 0 and pi. So we're looking at first quadrant values. So the question is this 0, pi over 6, pi over 4, pi over 3, or pi over 2? One of those numbers in the first quadrant has to be my answer. And so then the question we are then asking ourselves is, well, which of those values, which of those angle measures gives me a sine of 1/2? Okay, and so sine of 1/2 in this particular case would be our pi over 3. And so my answer is pi over 3. I'm sorry. That's cosine. Backing it up a little bit. My bad. Erase that. Pi over 3 does not give me a sine of 1/2. It gives me a cosine of 1/2. A sine of 1/2 would be pi over 6 in this particular case. And so my answer is pi over 6. Okay? And you can see that up above here as we did a quick reminder of our different values. Sine of pi over 6 is 1/2. Okay? Arc cosine of 0 then. Okay, so same thing. You need to start with identifying, okay, what quadrants am I even considering? Okay, so arc cosine. Arc cosine is between 0 and pi. I'm considering the first quadrant if my cosine is positive, the second quadrant if it's negative. In this case, I'm finding 0, which means I'm neither in the first quadrant or the second quadrant. What that tells me is that my answer is one of my axes angles. 0, pi, or pi over 2, one of those. Okay, and so then you'd be looking at, okay, well, what are my coordinates for each of those? Which one of those angle values would give me a cosine of 0? And in this case, the angle that would give me a cosine of 0 would be pi over 2. So we're looking here, pi over 2. Okay. Again, at some point, make sure you're pausing the video, trying these on your own. Okay, arctangent of root 3 then. Okay, so same thing. What quadrants am I even considering for this one? Arctangent. Arctangent is quadrants 1 or 4, 4 for the negatives, 1 for the positives. Okay, and so in this case, this is a positive root 3, so we're going to be figuring out which of my angles in my first quadrant here gives me a tangent of root 3. So that would be 0, pi over 6, pi over 4, pi over 3, or pi over 2. And so then you'd be checking each of them. What's the tangent of 0? What's the tangent of pi over 6? Etc., until you eventually landed on the fact that the tangent of pi over 3 is root 3. Y over x, sine over cosine. Again, if you came up here and did root 3 over 2 over 1/2, root 3 over 2 divided by 1/2, you'd get root 3. And so this answer is pi over 3. Okay, again, at some point, one more time, make sure you are pausing the video, trying these on your own, restarting it either when you are stuck or have an answer that you are ready to check. Okay, but I'm going to keep moving through these last 3. Number 4, arc cosecant of negative 2. And so we're figuring out, okay, what quadrant am I considering now? Cosecant is linked to sine, so it'd be negative pi over 2 to pi over 2. Right? Fourth for the negatives, first for the positives. In this case, this one is a negative value. And so we are considering angles down here in the fourth quadrant between negative pi over 2 and 0. Okay, so the question is, well, which of those angles, negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, or 0, gives me a cosecant of negative 2? Okay? Now, if you have your cosecant memorized, you might be able to figure this out pretty quickly, but a lot of people like to think of this as arcsine of negative 1/2, taking the reciprocal of that negative 2. So then the question is, well, which of these angles gives me a sine of 1/2 or a cosecant of 2? Okay, well, the angle that gives me a sine of 1/2 is my pi over 6 angle. So my answer is negative pi over 6. Again, pi over 6, sine of 1/2. Okay? Negative just because we're in the fourth quadrant for this one. Okay? Okay, number 5, arctangent of negative 1. So what quadrant are we considering now? Okay, well, arctangent is first, fourth. Negative 1 means for this arctangent, we are considering the fourth quadrant, stuff between negative pi over 2 and 0. So negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, or 0. Which one of these gives me a tangent of negative 1? Okay. So then you should end up landing on negative pi over 4. Because pi over 4, if I did my sine over my cosine or my y over my x, Root 2 over 2 divided by root 2 over 2 is 1 for tangent there. Okay. Negative 1, so negative pi over 4 for the fourth quadrant. Okay, and then arcsecant of root 2. Now for this one in class, I did modify this one to make it negative root 2, so let's go ahead and change that to negative root 2. Okay, then go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so secant, what quadrants are we considering? Secant is 1 and 2 between 0 and pi. This particular secant is negative, and so we are looking in the second quadrant between pi over 2 and pi. So the question is, will pi over 2, 2 pi over 3, 3 pi over 4, or 5 pi over 6, or pi? Which one of those gives me a secant of root 2? Okay, well, again, if you know your secants, you might be able to figure this one out already, but if you wanted to turn it into its reciprocal, arc cosine, you might prefer that, because then that helps you see that this one is my pi over 4 angle. And so in this case, we are naming it 3 pi over 4, because that's the angle that sits in the second quadrant between 0 and pi. Okay? And that's evaluating arc trigs.